ನಮಸ್ಕಾರ ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಲರ್ನಿಂಗ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸಿಸ್ಟಮ್ನಲ್ಲಿ ಅಂಡರ್ ದಿ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಆಫ್ ಕಾಲೇಜಿಯೇಟಿವ್ ಅಂಡ್ ಟೆಕ್ನಿಕಲ್ ಎಜುಕೇಷನ್ನಲ್ಲಿ ಥರ್ಡ್ ಇಯರ್ ENC ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಅಂದರೆ 5th ಸೆಮ್ಮಲ್ಲಿ ಬರುವಂತಹ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್ 154T ಯಲ್ಲಿ 5th ಯೂನಿಟ್ ಅಂದರೆ ಎಂಟರ್ಟೈನ್ಮೆಂಟ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಅಲ್ಲಿ 3rd ಸೆಷನ್ ಫೀಚರ್ಸ್ ಆಫ್ LCD ಪ್ರೊಜೆಕ್ಟರ್ಸ್ ಅಂಡ್ 3D ಕ್ಲಾಸಸ್ ಬಗ್ಗೆ ಇಂದಿನ ಕ್ಲಾಸ್ನಲ್ಲಿ ತಿಳ್ಕೊಳ್ಳೋಣ. ಹಾಗಾದ್ರೆ ನಾವು ಈ ಸೆಷನ್ ಏನೇನು ಕಲಿತೀವಿ ಅನ್ನೋದಾದ್ರೆ ಇಂಟ್ರಡಕ್ಷನ್ ಹೇಳ್ಬಿಡ್ತಿ LCD projectors, then working of LCD projectors and features of the LCD projectors, along with that applications of the LCD projectors. ಅದರ ನಂತರ 3-dimensional glasses ಅಂದ್ರೇನು and the classification of the 3-dimensional glasses ನ ನೋಡೋಣ. First we'll see what do you mean by projectors. ಪ್ರೊಜೆಕ್ಟರ್ ಅಂದರೆ ಏನು ಅಥವಾ ಪ್ರೊಜೆಕ್ಟರ್ ಹೇಗಿರುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಈ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಏನು ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ, ದಿಸ್ ಇಸ್ ದಿ ಪ್ರೊಜೆಕ್ಟರ್. ದೆನ್ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಪ್ರೊಜೆಕ್ಟರ್? ನೀವು ಇದನ್ನ ಎಷ್ಟೊಂದು ಕಡೆ ನೋಡಿರ್ತೀರಾ. ಹಾಗಾದ್ರೆ ಪ್ರೊಜೆಕ್ಟರ್ ಅಂದ್ರೆ ಏನು? ಸಿ, ಪ್ರೊಜೆಕ್ಟರ್ ಇಸ್ ಎನ್ ಆಪ್ಟಿಕಲ್ ಔಟ್ಪುಟ್ ಡಿವೈಸ್. ಏನಿದು? ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರೊಡ್ಯೂಸ್ ಅ ಔಟ್ಪುಟ್ ಏನಾಗಿರುತ್ತೆ? ಲೈಟ್. ಅದು ಆಪ್ಟಿಕಲ್ ಔಟ್ಪುಟ್ ದಟ್ ಟೇಕ್ಸ್ ವಿಡಿಯೋ ಆರ್ ಇಮೇಜ್ ಜನರೇಟೆಡ್ ಬೈ ಎ ಕಂಪ್ಯೂಟರ್ ಆರ್ ಎ DVD ಪ್ಲೇಯರ್ ಆರ್ even television signal and reproduce them on your screen or wall. See, projector ಅನ್ನೋದು ಒಂದು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸ್. ಇದು ಏನು ಔಟ್ಪುಟ್ ಕೊಡುತ್ತೆ? ಆಪ್ಟಿಕಲ್ ಅಂದರೆ ಲೈಟ್ ಸಿಗ್ನಲ್ ಕೊಡುತ್ತೆ. How it will take the electrical signal and it is going to produce a visual image on the screen. ಆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್ ಎಲ್ಲಿಂದ ಬರ್ಬೋದು? either it could come out of the computer or DVD player. ಸೊ ಪ್ರೊಜೆಕ್ಟರ್ ಅಂದ್ರೇನು? ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಪ್ಲೇ ದಿ ವಿಷುವಲ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಆನ್ ದಿ ಸ್ಕ್ರೀನ್ ಅಥವಾ ವಾಲ್. ಹಾಗಾದರೆ ಪ್ರೊಜೆಕ್ಟರ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಟೈಪ್ಸ್ ಇದೆ? ಸಿ, ಪ್ರೊಜೆಕ್ಟರ್ಲಿ 2 ಟೈಪ್ ಇದೆ. ಒಂದು LCD ಪ್ರೊಜೆಕ್ಟರ್ಸ್, ಇನ್ನೊಂದು DLP ಪ್ರೊಜೆಕ್ಟರ್ ಅಂತ ಹೇಳ್ತಾರೆ. ನಾವು ಈ ತರಗತಿಯಲ್ಲಿ LCD ಪ್ರೊಜೆಕ್ಟರ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ. ದಿಸ್ ಇಸ್ ದಿ ಡಯಾಗ್ರಾಮ್ ಆಫ್ ದಿ LCD ಪ್ರೊಜೆಕ್ಟರ್. LCD ಪ್ರೊಜೆಕ್ಟರ್ ಹೇಗಿದೆ? See, this is the diagram of the LCD projector. LCD projector andre the same. It is an optical output device which will display the image on the screen with the help of LCDs. ಈ LCD projector ಅಲ್ಲಿ ಏನಿರುತ್ತೆ? 3 LCDs ಇರುತ್ತೆ. ಅಂದ್ರೆ 3 LCD panels ಇರುತ್ತೆ. ಹಾಗಾದ್ರೆ ಈ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ನಾವು ಈ 3 LCD panels ಅಲ್ಲಿ ನೋಡ್ತೀವಿ. See, this is one LCD panel. This is another LCD panel. Third one is this is the third one, blue color LCD panel. See, this is the third LCD panel. This one is the blue color third LCD panel. This is also another diagram of the LCD LCD projector. See, this consists of one light source. ಇಲ್ಲಿಂದ ಏನು ಬರುತ್ತೆ? a white light will be emitted. Again there are 3 LCD panels. This one, another, this one. There are 3 LCD panels and there are 3 diachronic mirrors. ಏನಿರುತ್ತೆ? ನೋಡಿ, there is a one diachronic mirror, another diachronic mirror and another diachronic mirror. See, ಇಲ್ಲಿ ರೆಡ್ ಡೈಕ್ರಾನಿಕ್ ಮಿರರ್ ಇದೆ, ಇಲ್ಲಿ ಗ್ರೀನ್ ಡೈಕ್ರಾನಿಕ್ ಮಿರರ್ ಇದೆ, ಇಲ್ಲಿ ಬ್ಲೂ ಡೈಕ್ರಾನಿಕ್ ಮಿರರ್ ಇದೆ. ಸಿ, ನಮ್ಮ ಅಂದಿರೋಂಥ ವೈಟ್ ಲೈಟ್ ಏನಾಗುತ್ತೆ? ಈ 3 ಮಿರರ್ಸ್ ಮೂಲಕ ಪಾಸ್ ಆಗಿಬಿಟ್ಟು ಅಗೇನ್ ದೇ ವಿಲ್ ರೀಚ್ ದಿ LCD ಪ್ಯಾನಲ್ಸ್. ಅಗೇನ್ ಇಟ್ ಡೈಸ್ ವಿಲ್ ಬಿ ಕಂಬೈನ್ಡ್ ಇನ್ ಅ ಕಂಬೈನಿಂಗ್ ಪ್ರಿಸಮ್. ಅದಾದ್ಮೇಲೆ ಅಲ್ಲಿಂದ ಲೆನ್ಸ್ ಹತ್ರಕ್ಕೆ ಹೋಗ್ಬಿಟ್ಟು ನಮಗೆ ಇಮೇಜ್ ಏನಾಗುತ್ತೆ? ಪ್ರೊಜೆಕ್ಟ್ ಆಗುತ್ತೆ. ವಿಲ್ ಸಿ ಹೌ ಅ LCD ಪ್ರೊಜೆಕ್ಟರ್ ವಿಲ್ ವರ್ಕ್. We can see here there is a light source in which it will emit the white light. See, white light is nothing but it's a combination of 7 colors. Adರಲ್ಲಿ we are only interested in 3 primary colors. Primary colors ಯಾವ್ದು? RGB ಅಂದ್ರೆ red, green ಮತ್ತೆ blue. See, those 3 are colors as the primary colors. ನಾವು ಅದನ್ನ ಏನು primary colors ಅಂತೀವಿ? Because with the combination of all these 3 colors we could able to form any color. ನಾವು ಯಾವ ಕಲರ್ ಬೇಕಾದ್ರೂ ಮಾಡ್ಬೋದು. ಅದಕ್ಕೆ ಇವನ್ನ primary colors ಅಂತ ಕರಿತೀವಿ. See, this white light ಬಂದಿರೋದು, it will pass through the red diachronic mirror. Again it will pass through the green diachronic mirror. Again it will pass through the blue diachronic mirror. See, what do you mean by diachronic mirror? ಈ ಮಿರರ್ ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ this will allow only certain wavelength light. and it will reflect or it will reject the other lights. Red diachronic mirror ಏನು ಮಾಡುತ್ತೆ, it will allow only red color to pass through that. ಈ ಮಿರರ್ ಮೂಲಕ ಏನಾಗುತ್ತೆ, ರೆಡ್ ಕಲರ್ ಮಾತ್ರ ಪಾಸ್ ಆಗಿ ಈ LCD ಪ್ಯಾನೆಲ್ ರೀಚ್ ಆಗುತ್ತೆ. Again, this green color diachronic mirror will allow only green color light to pass through it to reach the LCD panel. This blue color diachronic mirror will allow only blue color light to pass through and it will reach the LCD panel. See, there are 3 LCD panels. Here one red, green and blue. See, this color will come and reach the LCD panels. For these LCD panels, they were going to apply electrical signal. ನಾವೇನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಯಾವ ಇಮೇಜ್ ಡಿಸ್ಪ್ಲೇ ಆಗಬೇಕಲ್ಲ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, we may apply the signal, electrical signal from the either from the computer or a DVD. 3 LCD panels ಕೂಡ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಕಲರ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಅಗೇನ್ ವಿತ್ ದಿಸ್ ಕಲರ್, ದಿಸ್ ಲೈಟ್ ವಿಲ್ ಗೆಟ್ ಮಾಡ್ಯುಲೇಟೆಡ್. ಈ ರೆಡ್ ಕಲರ್ ಆಗಿರ್ಬೋದು, ಗ್ರೀನ್ ಆಗಿರ್ಬೋದು, ಬ್ಲೂ ಆಗಿರ್ಬೋದು, ಏನಾಗುತ್ತೆ, ಇಟ್ಸ್ ಗೆಟ್ ಮಾಡ್ಯುಲೇಟೆಡ್ ವಿತ್ ದಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್. ಈ ಪ್ರೊಸೆಸ್ಸಿನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಆಪ್ಟೋ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಮಾಡ್ಯುಲೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ವಿತ್ ದಿ ಹೆಲ್ಪ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್ ನಮಗೆ ಆಪ್ಟಿಕಲ್ ಸಿಗ್ನಲ್ ಏನಾಗ್ತಾ ಇದೆ, ಮಾಡ್ಯುಲೇಟ್ ಆಗ್ತಾ ಇದೆ. ಹಾಗೇನೆ ಮಾಡ್ಯುಲೇಟೆಡ್ ಸಿಗ್ನಲ್ ಒಳಗಡೆ ಏನಿರುತ್ತೆ, ಡೈಕ್ರೋನಿಕ್ ಪ್ರಿಸಮ್ ಇದೆ. ಈ ಪೋರ್ಷನ್ ಅಲ್ಲಿ ಏನಾಗಿದೆ, ಡೈಕ್ರೋನಿಕ್ ಪ್ರಿಸಮ್ ಅಲ್ಲಿ ದೀಸ್ 3 ಕಲರ್ಸ್ ಆರ್ ಕಂಬೈನ್ಡ್ ಅಂಡ್ ದೇ ಆರ್ ಮೇಡ್ ಟು ಪಾಸ್ ಥ್ರೂ ದಿ ಲೆನ್ಸ್. ಲೆನ್ಸ್ ಮೂಲಕ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಬರುತ್ತೆ. ಇಟ್ ಕುಡ್ ಬಿ LCD ಸ್ಕ್ರೀನ್ ಆರ್ ಎನಿ ವಾಲ್ ಆರ್ ಸಮಥಿಂಗ್ ಲೈಕ್ ದಟ್. ಇಲ್ಲಿ ಬಂದಾಗ ನಮಗೆ ಆಕ್ಚುಯಲ್ ಪಿಕ್ಚರ್ಸ್ ಏನಾಗುತ್ತೆ, ಡಿಸ್ಪ್ಲೇ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. See, with the help of these 3 colors, we could able to form n number of numerous colors. ಅದು ನಮಗೆ ಪ್ಯಾನಲ್ ಏನಾಗುತ್ತೆ, ಡಿಸ್ಪ್ಲೇ ಆಗುತ್ತೆ. We will see how it works once again. A white light from the lamp is passed through a separation prism. The white light then splits into 3 primary colors. ನಾನು already ಹೇಳಿದಂಗೆ, what are the primary colors? Red, green and blue. Each beam of colored light is then fed to LCD panel, where lights are modulated by their corresponding electric currents called electro-optical modulation. For these 3 panels, we are going to apply the electrical signal either from DVD, player or television or computer. ಅಲ್ಲಿ ಕಂಪ್ಯೂಟರ್ ಇಂದ ಬಂದಿರೋ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್ ಈ ಲೈಟ್ಸ್ ಮಾಡಿಫೈ ಮಾಡುತ್ತೆ. We call that process as the electro-optical modulation. Again, a modulated light beams are combined into combining prism to form a single color image. The 3 lights ಅಂದರೆ LCD ಪ್ಯಾನಲ್ ಇಂದ ಬಂದಿರುವಂತಹ ಲೈಟ್ಸ್ ಕಂಬೈನ್ ಮಾಡಿಬಿಟ್ಟು ಒಂದು ಸಿಂಗಲ್ ಕಲರ್ ಇಮೇಜ್ ಮಾಡ್ತೀವಿ. ಆ ಇಮೇಜ್ನ ಲೆನ್ಸ್ ಮೂಲಕ ನಾವು ಪ್ರೊಜೆಕ್ಟರ್ಗೆ ಏನು ಮಾಡ್ತೀವಿ, ಸ್ಕ್ರೀನ್ಗೆ ಏನು ಮಾಡ್ತೀವಿ, ಪ್ರೊಜೆಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ದಟ್ ವಿಲ್ ಗೆಟ್ ನ್ಯೂಮರಸ್ ಕಲರ್ಸ್ ಔಟ್ ಆಫ್ ದಿ LCD ಪ್ರೊಜೆಕ್ಟರ್. ಅಂದರೆ ವಿಡಿಯೋ ನಾವು ಕೊಡೋಂಥ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್ ಕಂಟಿನ್ಯೂಸ್ ಬರ್ತಾ ಇರೋದ್ರಿಂದ ನಮಗೆ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಇಮೇಜ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಹಾಗೆ ಡಿಸ್ಪ್ಲೇ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ ವೇರಿಂಗ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿ ಇನ್ಪುಟ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್. The same thing is shown in a simplified way. There is a lamp which will emit the white light. This white light, there is a suppression prism. ಅಥವಾ ನಾವು ಡೈಕ್ರೋನಿಕ್ ಮಿರರ್ ಮೂಲಕ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಸಪ್ರೇಟ್ ಮಾಡ್ತೀವಿ. ಈ ರೆಡ್ ಡೈಕ್ರೋನಿಕ್ ಮಿರರ್, ಗ್ರೀನ್ ಆ್ಯಂಡ್ ಬ್ಲೂ ಟು ನಾವೇನು ಮಾಡ್ತೀವಿ, ಸಪ್ರೇಷನ್ ಪ್ರಿಸಮ್ ಇಂದ ನಾವು 3 ಲೈಟ್ನ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಸಪ್ರೇಟ್ ಮಾಡ್ತೀವಿ ಥ್ರೂ ವಿತ್ ಹೆಲ್ಪ್ ಆಫ್ ಡೈಕ್ರೋನಿಕ್ ಮಿರರ್. ಯಾವುದು, ರೆಡ್, ಗ್ರೀನ್ ಮತ್ತು ಬ್ಲೂ. ದೋಸ್ 3 ಕಲರ್ಸ್ ಆರ್ ಅಪ್ಲೈ ಟು ದಿ 3 LCD ಪ್ಯಾನಲ್ಸ್. ಯಾವುದಿದು, ರೆಡ್ LCD ಪ್ಯಾನಲ್, ಗ್ರೀನ್ LCD ಪ್ಯಾನಲ್ ಅಂಡ್ ಬ್ಲೂ LCD ಪ್ಯಾನಲ್. To say 3 of these LCD panels, we are going to apply the electrical signal. ನಮಗೆ ಐದರ್ DVD ಇಂದ, ಪ್ಲೇಯರ್ ಇಂದ, ಅಥವಾ ಟೆಲಿವಿಷನ್ ಇಂದ, ಅಥವಾ ಕಂಪ್ಯೂಟರ್ ಇಂದ ಬಂದಿರೋ ಅಂತ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸಿಗ್ನಲ್ ನಾವು ಎಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಟು ದೀಸ್ 3 ಪ್ಯಾನಲ್ಸ್. ಇನ್ ದಿಸ್ ಅಗೇನ್ ದಿ ಲೈಟ್ ವಿಲ್ ಗೆಟ್ ಮಾಡ್ಯುಲೇಟೆಡ್. ಮಾಡ್ಯುಲೇಟ್ ಆಗಿರೋ ಅಂತ 3 ಸಿಗ್ನಲ್ಸ್ನ ನಾವು ಪ್ರಿಸಮ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಮತ್ತೆ ಏನು ಮಾಡ್ತೀವಿ, ಕಂಬೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ವಿತ್ ದಿ ಹೆಲ್ಪ್ ಆಫ್ ಲೆನ್ಸ್ ನಾವು ಅದನ್ನ ಎಲ್ಲಿ ಫೋಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ನಮ್ಮ ಸ್ಕ್ರೀನ್ ಮೇಲೆ ಫೋಕಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ದಿಸ್ ಇಸ್ ಅ ವೇ ಹೌ ವಿ ಗೆಟ್ ಇಮೇಜಸ್ ವಿತ್ ದಿ ಹೆಲ್ಪ್ ಆಫ್ 3 LCD. ನಾವು ಇದನ್ನ ಏನು 3 LCD ಅಂತೀವಿ ಅಂದರೆ, ಬಿಕಾಸ್ ದೇರ್ ಆರ್ 3 LCD ಪ್ಯಾನಲ್ಸ್. ಏನಿದೆ, 3 LCD ಪ್ಯಾನಲ್ಸ್ ಇದೆ. Then we'll see what are the features of LCD projectors. Before that, we'll see a video how an LCD projector will work.
Projectors are everywhere, from the classroom to the home theater to the conference room. And one technology has powered more projectors than any other. That technology is 3LCD. There are several reasons why 3LCD has been so successful. 3LCD is famous for outstanding color reproduction. On average, 3LCD projectors use less energy than the competitive technology. 3LCD technology was invented 20 years ago. That's 20 years of development, research, and innovation. 3LCD makers have sold over 60 million LCD chips. This success is called road-tested reliability. 3LCD is built around 3 discrete LCD chips. These tiny liquid crystal displays are similar to the LCDs found in televisions, monitors, notebook computers, even telephones. Why are there 3 imaging chips? All colors in a projected image are made through combinations of the 3 primary colors of light, red, green, and blue. White light is formed when pure light from all 3 primary colors is combined. That is why all 3 LCD projectors use 3 chips, one for each of the 3 primary colors. In fact, all major projection technologies have 3-chip versions: LCD, LCOS, even DLP. Unlike DLP, all 3 LCD projectors have 3 separate imaging chips. Most DLP projectors get by with a single imaging chip. At the heart of 3LCD is a prism and the 3 liquid crystal chips. The 3 discrete LCD chips produce clear, colorful images and make the 3LCD system light efficient. Other components are the lamp, the dichroic mirrors, and projection lens. Lamp light is divided by dichroic mirrors into the 3 primary colors of light, red, green, and blue. Dichroic mirrors are special optics that reflect certain colors while allowing other colors to pass through. For example, first, red light is reflected towards the red LCD. Green and blue light easily passes through this first dichroic mirror. The second dichroic mirror divides green and blue, completing the separation of 3 beams of light. The 3 beams are then directed towards the 3 dedicated LCD chips. After the light has permeated the LCDs, the colors are recombined in the prism to produce rich, colorful images, which are then projected by the lens. By using 3 separate chips, 3 LCD projectors efficiently use light energy and create beautiful, colorful images.
Students, we have seen how LCD projector works. We'll just revise once more. We'll get a light from light source, and in this prism or with the help of dichroic mirror, we could separate 3 colors, and those lights will be sent to the corresponding LCDs, red LCD, green and blue LCDs. To these LCDs, we are going to apply electrical signal. Then the light will get modulated, and that will be combined in a combining prism that will be focused with the help of lens to the screen. This is how a picture is produced with the help of LCD projectors. We'll see what are the features of the LCD projectors. See, the technology, this LCD projector technology is so established and it's reliable than other film projectors. See, there are other projectors like DLP projectors and all, but comparatively, this is more trustworthy and reliable than the other projectors. The next advantage feature is this projector doesn't have any moving parts, so it's very easy to handle. The third one is it is less expensive than the DLP projectors. Even though the expense is very less, but still it offers the bright, sharp pictures with vibrant, rich colors. The next feature is LCD projectors are compatible with the zoom lenses. See, we can zoom the pictures produced from the LCD projector so that we can see the even more larger surfaces. We can see the videos or pictures and the larger surfaces. So next feature is LCD projectors provide greater brightness with lower energy consumption. See, compared to other projectors, it will consume very less energy, electricity, and it will produce the very greater brightness, vibrant, rich colors. See, the next advantage feature is, see, LCD projectors do not suffer from the rainbow effect like DLP projectors. Another DLP projectors, they have a rainbow effect. In the sense, in some pictures, the colors will be spreaded, but this LCD projector doesn't have such problem. These are the features of the LCD projectors. We'll see what are the applications of the LCD projectors. See, we can use LCD projectors are used to display the images, videos, or computer data on the screen or flat surface. So where we can use in a teaching or to give a presentation to make the digital classes. Or we can use at homes in order to watch the movies on a big screen. See, if television is a small screen, so instead of that, if we can make it as a home theater and we can watch the movies on a big screen with the help of LCD projectors. See, next advantage is our applications. We can use this in industries, business meetings, or public gathering for displaying the required data or in order to handle the meetings, in order to carry out any sessions, public meetings. With the help of LCD projectors, we can display the data over the larger screen. These are the applications of the LCD. Next, we'll see the next concept, three-dimensional glasses. 3D glasses. Three-dimensional glasses is nothing but the 3D glasses. Students, you have heard of glasses and you have seen or some might be using. Why do we use the glasses? For any visual correction or in order to protect our eyes from harsh environment. Maybe in order to protect our eyes from UV rays or some direct sunlight or dust particle, we generally use the glasses. Then what do you mean by three-dimensional glasses? Why do we going to use the three-dimensional glasses? See, these are the special glasses. These three-dimensional glasses are the special glasses in order to watch the 3D movies. Three-dimensional movie ನೋಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡುವಂಥ ಸ್ಪೆಷಲ್ ಕ್ಲಾಸಸ್ ನಾವು ಏನಂತ ಕರಿತೀವಿ? 3D classes ಅಂತ ಕರಿತೀವಿ. The 3D classes, specialized classes used for viewing the 3D movies. It could be 3D movies or it could be some specific visual information or some special video. See, some specific visual information ಆಗಿರ್ಬೋದು ಅಥವಾ 3D special videos ನಾವು ವಾಚ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. 3D classes ಯೂಸ್ ಮಾಡ್ತೀವಿ. Then how this special video, the specific visual information ಹೇಗಿರುತ್ತೆ? See, special videos are designed in such a way that one image is seen to left eye and another image is intended only to the seen by right eye. With binocular vision technology, our mind articulates the video information as 3D. ಓಕೆ, ಹಾಗಾದರೆ ನಾವು ಈ ಥರ ಗ್ಲಾಸಸ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಹೇಗೆ 3D ಮೂವೀಸ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಹೇಗೆ ನೋಡ್ಬೋದು ಅಂದರೆ, see, this special video consists of two separate images, one for left eye and another for right eye. ಅವು ಎರಡು ಇನ್ಫಾರ್ಮೇಷನ್ ನಮ್ಮ ಬ್ರೈನಿಗೆ ರೀಚ್ ಆದಾಗ ವಿತ್ ಬೈನಾಕ್ಯುಲರ್ ವಿಷನ್ ಟೆಕ್ನಾಲಜಿ ಅವರ್ ಬ್ರೈನ್ ವಿಲ್ ವೀವ್ ದಟ್ ಆಸ್ ದಿ 3-dimensional picture, 3-dimensional movie ಥರ ನೋಡತ್ತೆ. See, what then 3D glasses does, it just facilitates the transmission of left intended image to the left eye, right intended image to the right eye. Then in turn our brain will visualize that as the 3D image. Okay, we'll see. Then again, a 3D movie viewed without a glass may appear to be out of focus because same scene is projected simultaneously from two different angles. See, if you see the 3D movie without the 3D glasses, ನಮಗೆ ಅದು ತುಂಬ ಕ್ಲಿಯರ್ ಆಗಿರಲ್ಲ. ಅಂದರೆ ಒಂದೇ ಇಮೇಜ್ ಎರಡೆರಡು ಸರಿ ಸ್ವಲ್ಪ ಟೈಮ್ ಗ್ಯಾಪಲ್ಲಿ ಡಿಸ್ಪ್ಲೇ ಆಗೋ ಥರ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ, ವಿಷನ್ ಬ್ಲರ್ ಇರುತ್ತೆ ಅಥವಾ ಔಟ್ ಆಫ್ ಫೋಕಸ್ ಇರುತ್ತೆ. ಬಿಕಾಸ್ ದ ಸ್ಪೆಷಲ್ ವಿಡಿಯೋ ವಿಲ್ ಕನ್ಸಿಸ್ಟ್ ಆಫ್ ದಿ ಟೂ ಸಪ್ರೇಟ್ ಇಮೇಜಸ್, ಒನ್ ಫಾರ್ ಲೆಫ್ಟ್ ಐ ಅಂಡ್ ಅನದರ್ ಫಾರ್ ದಿ ರೈಟ್ ಐ. ಓಕೆ, ಹಾಗಾದರೆ ನಾವು ರಿಯಲ್ ಆಗಿ ನೋಡ್ತೀವಲ್ಲ, ಪ್ರತಿಯೊಂದು ಕೂಡ 3-dimensional ಇಮೇಜ್ ಕಾಣಿಸ್ತಿರುತ್ತಲ್ಲ, ನಮ್ಮ ಐಯಿಂದ ನೋಡಿದಾಗ, ನಮ್ಮ ಕಣ್ಣಿಂದ ನೋಡಿದಾಗ ಅದು ಹೇಗಾಗತ್ತೆ? We have a binocular vision technology. We have two eyes. They're slightly different places. ನಮಗೆ ಎರಡು ಐಸ್ ಏನಾಗಿದೆ, ಸ್ಲೈಟ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇದೆ. ಪ್ಲಸ್ ವೆನ್ two different images will be sent to your brain. In turn, your brain will articulate that as the 3-dimensional image. ಅಥವಾ 3-dimensional picture ಥರ ನಮ್ಮ ಬ್ರೈನ್ ಏನು ಮಾಡುತ್ತೆ, ಆರ್ಟಿಕ್ಯುಲೇಟ್ ಮಾಡುತ್ತೆ. ದಿ ಸೇಮ್ ಪ್ರಿನ್ಸಿಪಲ್ ಇಸ್ ಅಪ್ಲೈಡ್ ಇನ್ ದಿ 3D glasses. 3D glasses ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, there will be two separate glasses. One will in the 3D movie there will be two separate images. One is intended for one eye, another image is intended for the other eyes. Our brain in turn will articulate that as the from 2D image to 3D image. The 3D glasses have a color filters that separate two different images and cause one image to enter one eye and another image enter to the other eye. Thus, 3D glass provides separate image to each eye. Then our brain combines these two images and it will view 2D signal as a three-dimensional movie, three-dimensional image. See, in this picture, you can able to see how 3D glasses works. This is a television. In the sense, there are two images coming from the television. One is red, a red colored image. I mean, one set of image, and another is red colored image. Two set of images. In a sense, television will special video will tell you two images, one for the left eye and another for the right eye. See, this is a three-dimensional glasses. Each has a blue filter. This has a red. I mean, in a sense, red filter. This blue filter will filter the blue light. Will allow only red color in red color to enter into our brain. This red filter will reflect, in a sense, it will filter the red light and allow only the blue color image to be get into the our eye. In turn, our eye will transmit these two images into our brain. Then with a slightly different time. So brain will articulate this image as a three-dimensional image. This is how 3D glasses works. See then how 3D glass will look. We have seen in the diagram. This is the 3D glass. Then what are the classification of the 3D glass? There are two classifications. One is active polarized glasses and another is passive polarized glasses. We'll see in detail what we mean by passive polarized glasses. Then we'll see what we mean by active polarized glasses. See, first we'll learn about the passive polarized glasses. See, these are the examples. These are the diagram of the passive polarized glasses. See, they look like a normal glasses. They look like a normal glass. They don't require any external power supply to work. They just have a color filters. Here is a green color filter. This is a red color filter. They just have filters in order to filter the colors. See, have filters that separate two different images. They look like a normal sunglasses, require no power supply to work. Then what are the advantages of the passive polarized glasses? They are lightweight. The weight of the glass, in a sense, glass is very less. This is inexpensive. The cost of the passive polarized glass is very low. There is no flickering effect. It's very comfortable to view and it's very comfortable to place and relatively less eye damage even after long view. Even if you watch a movie for 3-4 hours, there is relatively eyes won't get strained with the help of passive polarized glasses. But only the disadvantage of passive polarized glasses, the resolution of 3D glasses is 50% less than 2D images because every time two images will be sent. One is for left eye and another for right eye. So the resolution is 50% less than the 2D images. Then we'll see what we mean by active polarized glasses. See, these active polarized glasses consist of active shutters. Shutters in order to open and close. The active shutter 3D glasses are small LCD screens that alternately open and close the left and right lenses. The glasses, they contain shutters and they will open and close automatically in a rapid succession with the help of shutters. So each eye can see the image intended for it. In passive polarization glasses, we have a separate color filters, but here we don't have any such color filters. One time, one glass will remain open, another will be closed. Next second, one glass will remain closed, another glass will remain open. This will be done with the help of shutters. These shutters will run in such a rapid fashion, our eye cannot make a notice. Another thing is with these active polarizing glasses, the shutter open and closing rating should be synchronized with the on-screen display rate. The next thing is they are bulkier because they have shutters. In order to open and close the shutters, we need a power to operate. They will come with the batteries and electronic circuitry in order to open and close. Since these are expensive, so because they have to come with the shutters plus as well as the battery in order to open and close. These are expensive because there are extra electronic circuitry included compared to the passive polarized glass. But the one advantage is that the resolution of the 3D image with active polarized glass is same as that of 2D image. Then what's an advantage? As I told, the resolution of the 3D glass is same as that of 2D image. Then what is the disadvantage of the active polarized glass? In this, the flickering is more due to rapid opening and closing of the shutters may be detectable. See, some people when they use the active polarized glass, they could able to make out the opening and closing of the shutters. So this will cause too much discomfort to watch the video because every time they feel something is opening and closing in front of their eyes. The next disadvantage is these are bulkier, in a sense heavier. They have more weight because they have an external electronic circuit in order to open and close the glasses. The third disadvantage is they need battery to operate. See, whereas passive doesn't need any battery power, but active glasses they need battery power in order to operate. This is next one. The next disadvantage is expensive than passive glasses because of the additional circuitry. Since there are shutters, battery, and electronic circuit to control the opening and closing of the glasses, these are comparatively expensive and they need a lot of maintenance compared to the passive 3D glasses. Students will see a video how 3D glasses will work.
Hello, and welcome to another BNext 3D video tutorial. In this tutorial, we will show you the difference between the types of 3D technologies and glasses. Once you're finished, don't forget to watch our other 3D tutorials at www.howtosetup3d.com. In order to understand the difference between the 3D technologies and glasses, we first need to understand how 3D works. 3D content has two sets of videos, or frames, one for each eye. In order to see the 3D effect, we need to make sure that each eye sees only the video or image that is intended for it, which is why we use 3D glasses. All the 3D glasses are equipped with special lenses that make sure this will happen. They filter only the left frame to the left eye, and the right frame to the right eye. The difference between each type of 3D glasses is in the way they do that. Let's go over the main types of 3D glasses and technologies being used today. Anaglyph 3D glasses are the simplest type of glasses of the ones we will discuss here. They have lenses in two different colors, usually red and cyan, but other color combinations can be used, such as green and magenta. The colored lenses of the glasses filter each frame to its designated eye, corresponding to color differences in the 3D movie. The main advantage of Anaglyph 3D glasses is the low price and that there is no need for a special display for watching Anaglyph 3D. You can use any standard display, or even print an Anaglyph picture on a paper. The disadvantage of Anaglyph 3D glasses is the low 3D quality they offer. This is why they are not currently being used in any of the modern cinemas or with 3D TVs today. Active shutter 3D glasses are commonly used with 3D TVs, 3D projectors, and in some cinemas. Each lens contains transparent liquid crystal that turns black once a voltage is applied, blocking one of the eye's sight at a time. The glasses get instructions from the emitter or screen to darken each lens at the right time, while the screen presents a different movie image to the unblocked eye for the completion of the illusion. For example, when the left lens turns black, only the right eye sees the image that the screen intends for, or vice versa. There are a few ways communication occurs with active shutter 3D glasses, through an infrared emitter, a radio frequency emitter, or a DLP link that uses a flashing technique instead of an emitter. 3D TVs and 3D PCs will usually use an emitter, whereas DLP projectors will usually use the DLP link technology. The 3D effect is very good when using active shutter 3D glasses. The main disadvantages are that they are expensive, that they are not very comfortable, and there is flickering, which can sometimes cause mild dizziness. Polarized 3D glasses are the most common glasses used in cinemas today. The glasses have special lenses that filter the intended frame to the correct eye, using differences in light polarization or direction. To use these glasses, a compatible 3D display or projector is required, which polarizes light differently for each eye. The advantages of polarized 3D glasses are that they provide a very good 3D effect, and the glasses are cheaper and more comfortable than the active glasses. One of the disadvantages of polarized 3D glasses is the need to use a special silver screen with a projector, which makes the system more expensive and slightly decreases the 3D effect in comparison to the active systems. There are two main types of polarization: linear.
Students, we have seen how 3D glasses works. For any doubts or clarification, you can get back to us at lms.dtech@gmail.com. Thank you.